Hello, good evening everyone. So today is our live lecture for this course. I have got several questions from some of you, and that I will take it, and then you can also ask me questions right over here. I can see Janaki, Chandu, Georgie, and Ajit. Hello everyone. Um so I have also received some questions from Arun, Abhay, Alicia. So I'll take one by one, right? Okay. The first question is from Wilfred Molongo, and the question is, what are some of the medical devices which can be made at a low scale to be used in both rural and urban hospitals? I want to help people, especially rural communities, who lack proper treatment because of proper equipment. So there are several medical devices or several actually diseases that we can think of where you can design and develop a medical tool or a system that can be directly used for people near primary healthcare centers or even secondary healthcare centers. Which are those devices? So those devices are, one is oral cancer. Oral cancer in India is at peak, and the way to detect oral cancer is that first there is a cytology study. Cytology study is a study of cells. If the result comes as atypical, that means the cells are taken using a swab, sent it to the tertiary clinic. There the pathologist would smear the cells on glass slide after performing H&E staining. If the cell cytoplasm ratio is different, there is double nucleation, in general cell morphology is different, then the person is asked to travel to the tertiary clinic where the histology is done, that means tissue is taken out. This is a time consuming process. So can we develop a system that you can place right at the primary healthcare center, and as soon as the swab is taken, the cells are taken, you can smear the glass on the glass slide. When I say you, doesn't mean actually a subject, means a ASHA worker or semi-skilled personnel. So if ASHA worker can take the cells, perform H&E staining, smear it on glass slide and load it in the system and press a button. These images that will be there, it will scan entire images. Our system should scan entire images of all the cells and send it to the remote pathologist. What happens is the travel time from the testing or taking the swab all to the way to the result of cytology reduces, because now you are remotely transferring the data from one center to the expert at other place, right? There is one system. So can you develop a cytology based screening tool for oral cancer? One example. Second example is for cervical cancer. In fact, few groups are already working on this particular domain of identifying cervical cancer, screening of cervical cancer. The third important point would be in the screening of neonatal hearing. So what is neonatal hearing, right? When the baby is born, generally a system called BERA, or the technique called BERA is used. It's a brain evoke potentials, and the system cost is about 14 lakh, 14 lakh. So only tertiary clinics have this system, at least in our country. So can we develop a band that you can place on the newborn baby and can tell whether the baby can hear or not? This BERA system works very simple. The principle is very simple. You give a stimulation which is audio stimulation, and you put an electrode which is in the frontal lobe, frontal region, right? FZ, and you can get the EEG signal. That shows from the cochlea to your auditory thalamus if the circuit is correct or not. A quick process, so you can develop a screening tool for the same. Next is a remote or portable system for understanding thyroid. Thyroid is another very important problem in our country, and the way to detect is also very complex. Can you detect thyroid just by drop of blood? So there can be many devices that you can think of once you understand the human physiology, once you understand the importance and the gap existing in this particular domain. And of course, when I say it seems very easy, but when you implement it, there are a lot of complexity that will come into effect. Nevertheless, we can always try to work in a group to fabricate or develop this kind of systems. All right. So that is the answer to Milfred Malongo. Let me take the second question. And by the time, by the point, by the way, you can type the questions right in this live chat also. I'll take your questions as well. Those who are attending this particular live session. Okay. So the second question is from Kausik Vyash, and Kausik is asking. Okay, you can call me Hardik, by the way. Don't call sir. Right? Sir C.V. Raman, right? He did something which is worth calling him sir, right? I'm a teacher. You can call me by name. It's absolutely fine. So anyway, the question is, please explain. It is written here, sir. Sir, please explain. That's why I said just to call me Hardik. It's okay. So please explain dry etching and wet etching and its classification with advantages and disadvantages. Okay. See, the platform that we are right now using does not allow me to write down something and share the screen. Okay, so I'll try to tell you the advantages and disadvantages of dry versus wet etching. Okay, first is when the etching is required. So let me take an example. All right. Let us say this is a silicon wafer. I am showing you a cross section of silicon wafer. All right. And suppose there is a piezoresistive sensor integrated onto silicon wafer. Now, what's the role of piezoresistive sensor? When you apply a pressure, there is change in resistance. As simple as that, right? So if I apply a pressure, would there be change in resistance? That change in resistance depends on how the substrate will bend, right? The substrate, which is right now straight, should be bending like this, right? But this is a hard substrate. It cannot bend. Now assume that this is silicon. It's a silicon. So when you apply a pressure, this substrate should bend. When there is a stress, there is a change in resistance, right? So of the piezoresistor that is integrated onto the substrate using boron diffusion. So what I will do is I will etch some 400 microns. Assume that this is a 4-inch wafer, 4-inch wafer diameter. That means thickness is how much? 500 microns, right? We know it. So for 500 microns wafer, if I etch 400 micron silicon, I have to perform wet etching, right? I have to perform wet etching. Wet etching or dry etching. Etching of a material from the substrate, or if I deposit any material and if I want to etch that material, I have to remove that material. That is your etching. All right, etching is easy. Now, how much you are etching depends on the micro machining technique. That is bulk micro machining that we performed here. There are two types of micro machining technique. We will only talk about bulk micro machining for this question. So now the another point is whether I should go for wet etching or I should go for dry etching, right? And which one is better? You see, wet etching, for example, if you take a silicon wafer or silicon as a material, silicon can be etched using potassium hydroxide or TMAH. Both are chemicals. We have to dip the silicon in this chemical to etch, right? That's why, because both are chemicals, they're called wet etching technique. The process is called wet etching technique. Having said that, let us first understand wet etching and the advantages, disadvantages versus dry etching. In wet etching, if I use KOH versus TMAH, then there are further parameters. For example, KOH can be used at 80 degrees centigrade. TMAH is used at 25 degrees centigrade. In KOH, you will have rough edges. In TMAH, you have smooth edges. KOH is faster, TMAH is slower, right? That means that TMAH will give you smooth surface, but it's slower etching time. KOH will give you rough surface, but it's faster in etching. So which one you will select depends on the application, because whether you are okay with your etched area to be corrugated or rough, or you want it to be perfectly smooth, depending again on the application. Now that is about your wet etching. If I compare that wet etching with dry etching of silicon is done using DRI, which is called deep reactive ion etching. When I'm talking about 400 microns etching, so you have to etch quite deep into it, right? So after 500 microns, if I etch 400 microns, I'll use DRI. You also have a chlorine etcher and a fluorine etcher, again used for etching some metals and some semiconductors. or insulators. But the advantage of dry etching here is that you will have a perfectly angled wall. There is no 54.6 degree angle that you see with wet etching. All right. So the quality of the diaphragm that you create with dry etching would be better than the quality of the diaphragm that you create for wet etching in this particular case of a pure pressure sensor. All right. So that's how you have to think about it. What is the application? For that application, how can I use, what are the different parameters that I can use it? Provided you don't have to worry about DRI always. All right, you can use a wet etching in your laboratory because DRI itself is like 2 3 crores 4 crores. So we may or may not have DRI everywhere. For you to fabricate devices, not every device would require DRI. You can go for chemical etching, wet etching, but these chemicals are also harmful. For example, TMAH is very harmful. So you have to use wet benches, all right, with proper exhaust system, with a proper environment, and there's a way to use wet benches. You cannot put your head inside the wet bench because then you will smell those vapors, right? So only your hand should go in. Lot of things are there, but my point is that you need to select the process depending on the equipment and the technology available with you. If everything is available, I will go for dry etching, right? uh, Another advantage and disadvantage: in dry etching you can use one wafer, in wet etching you can use all 25 wafers simultaneously. So you can etch all 25 wafers, 400 microns, 400 microns, 400 microns, for 1 to 25. In dry etching, one wafer, you etch it, remove it, put second wafer, etch it, remove it. So that is a time constraint that we need to think about. Okay, before taking the third question, let me answer Ajit's question. Ajit is asking, can we fabricate sensor in college lab? Absolutely yes, we can. Again, you need to think what kind of facilities you have in the college, right? In your college. Sometimes not all the colleges would have facility required for fabricating some of the micro sensors, but that does not mean that you cannot fabricate sensor, because there is something called screen printing technology, right? You know it. If you don't know it, earlier we used to print all our invitation cards, whether marriage invitation or birthday invitation, right? Using screen printing, you have a screen in which you put the coating and only remove certain part, which is your pattern. Then you put the screen on the material on which you want to transfer the pattern. Take the paste, take squeegee, and then and move the paste across the screen. Lift the screen and the same pattern will be transferred, which is on the screen, onto your substrate or onto the material on which you want to print it. If I now can print aluminum electrodes on which I can print your sensing material, then it becomes your sensor, right? So you can design certain sensors, you can fabricate certain sensors in a given lab environment if the facilities are not sufficient for you to fabricate. That's the answer, Ajit. Yeah. Okay. So let me take one more question from Snehal. And the question is, we discussed about orientation of wafer like 111, 100, etc. What will be difference in using different orientation? Okay. So generally, Snehal, when we had to fabricate a sensor, and the example that I have taken is of a piezoresistive pressure sensor, in which we talked about micro machining, and that too also bulk micro machining. In that case, we will like to go for 100. 100 wafers are preferred for etching or bulk micro machining or surface micro machining. We don't use 111 kind of wafer. All right. So there is a simple difference between 100 and 111 in a very simplistic way. All right. I'll just take another question again from another student, Vishnu. And Vishnu is asking, what type of metal oxide semiconductor material can be used as a promising candidate for future gas application? Is CO2 good material for this purpose? See, I don't know whether CO2 it will be good for which purpose. Like just gas sensor, there when you say gas sensor, which gas? right? Depending on the gases that you are targeting, you have to select your sensing material. Not every time you have to have a gas sensor which is made up of metal oxides. You can also have gas sensors which is colorimetric in nature. You can have a micro GC, micro gas chromatography, right? But for the semiconductor oxide, if you select, I believe that your selectivity would improve when you use array of sensor rather than one single sensor. One single sensor to be selective and sensitive is kind of difficult. All right, not impossible, difficult. So, but the advantage is that if I use a thin film, the sensitivity will not be that great compared to my nanostructure film. The reason is because nanostructure would have a higher surface to volume ratio compared to thin film. So depending on material and depending on the type of application, I have to select semiconducting oxide materials. Um, uh, we generally kind of use zinc oxide, indium tin oxide, mixture of tin oxide and indium oxide, which is called indium tin oxide, is ITO. We also use WO3 and then CO2 and many more. But again, depending on the application that you are looking at and what kind of gases you want to detect. Hmm? So uh, see, I have not. Let me take another question, which is from Raj Kumari. I have not taken any example of RF MEMS, isn't it? So this is out of the syllabus for this particular course. However, I would definitely love to explain RF MEMS, or in fact send you a lot of important process flow regarding RF MEMS. But as I said at the starting of this class, this live lecture, of course, I'm used to say class. So live lecture is that I don't have a way to write down on this board like I used to record it in the studio. So even though I want to teach you RFMs here, I cannot teach you because there is no way to for me to write down here. All right. So what I will request is send me an email. I'll draw a process flow. I'll send it back to you, or I'll send you papers related to the RFMs. It's very simple. In one way, I can just try to explain you uh, somehow. All right. So okay, you have your silicon wafer, oxidized silicon wafer. Now you create a pit. All right, you create a pit means you etch silicon from the top. Then fill that pit with zinc oxide. You understood? You have silicon. You create a pit, like means you etch silicon, let's say 5 micron, and then you fill silicon that is your the pit with zinc oxide. Now on this you deposit a metal. All right, you deposit a metal and then dip this wafer metal and then pattern it so it looks like just a line like this. All right, then dip this wafer in 1% HCl. What happens is the zinc oxide, which is sacrificial layer, will come out and you have a cantilever. Now this is just one part of the switch, right? So what you have to do is you deposit an electrode on the bottom, then create this pit, then create another cantilever, and then on this pit you deposit zinc oxide, etch it. There is another line, and there you have your bottom electrode, you have the top electrode. When you apply DC versus RF, you will see that there is a vibration. Again, very difficult to teach you like this, like taking an example. But I would still want you to send me an email. I'll just type down my email in case you guys don't have. Just make sure that the question that you ask are really very difficult that you cannot solve. And this particular forum right now that we are using, which is your live session, is for asking questions which is related to this course. All right. So try to stick within that frame. PANDYA. Yeah, this is my email ID. So you can send me an email with a question which is outside the syllabus. Okay. Kaushik, why you want me to set the table of chemicals? Because depending on material that you want to use, when you type it, you will get the answer immediately in Google 1 minute, right? There are hundreds of materials, so we don't use those materials. So no point of having a table in front of you. Write down zinc, you will have the HN. Gold, you have Ki. Then silicon, you have KOH or TMAH. So there is a lot of possibilities of writing new chemicals, and not new chemicals, materials and the etchant. So it's easy. We also do like this only. All right, either we look at the literature, we type the material and etching, and we perform the experiment. So no need of having that table in front of you. Uh, I don't know. Okay, here we are asking about OpAmps. I think when you go to the NPTEL forum and not NPTEL forum, actually to the NPTEL website, and for the course there is a syllabus. In the syllabus, at the end of the syllabus, you will see list of books for all the courses. If you cannot find it, send me an email. I'll reply back to you for which subject, which books you can refer. For this particular course, if you ask me such actuators, some of the things that I am teaching you would not be available in books. I am teaching you which is a little bit not really advanced but not really basic also. So some of the examples that I have taken is out of my research interest, and the fabrication of some sensors or some drives, right? That is only out of the research interest. Some of the research topics that I have taught, which may or may not be available in books. So that's why my lecture should be enough for you to get things rolling. All right, let me take another example from the this file, and I have question from Lalit Kumar. Can we make piezoelectric sensor at lab? If yes, then can you explain the process? Yes. Okay, yes. The answer is, what is piezoelectric sensor? Piezoelectric sensor is sensor when you apply pressure, there is a change in voltage, or when you excite the sensor, there is a change in pressure, right? Either of. So can we fabricate this? Yes, we can. How to fabricate this? So piezoelectric sensor works different than piezoresistive. In piezoelectric sensor, you have a bottom electrode, then you have a sensing layer, which is a piezoelectric material, and then you have a top electrode. So let's say my hand is a bottom electrode, then you have a sensing layer, and then you have top electrode, such that the top electrode should not. So I'll just draw top electrode like this, so that the top electrode will not be in contact with the bottom electrode, otherwise it's short, right? Then when you excite this one, right, it will start vibrating. Or you apply a pressure, there is a change in voltage that we can measure across the two electrodes. So that's how the piezoelectric sensor would work. There is a new interest in research which is on MUTs, which is a micro machine ultrasound transducers. It can be capacitive, it can be piezoelectric. So depending on again the application, you can design and fabricate these piezoelectric sensors or transducers. The material that you have generally use are aluminum nitride, PVDF, PZT, lead zinchromium titanate. And the way to deposit is either by sputtering or by sol gel, by spin coating it onto a wafer and by annealing it at a certain temperature depending on the chemistry that is there. So that is a answer to your question, Kaushik. Sorry, this was from Lalit Kumar. Okay, let me take another question. Yeah, so you see, photolithography generally we use contact based photolithography, right? Then there is a proximity lithography, and then there is a projection lithography. So these are the way to define lithographies. Now the modality, that is either photolithography or e-beam lithography or X-ray lithography. So this is how you divide further depending on the pattern that you are looking at. So that's how we design lithography, and we design the process for lithography. There is a direct patterning and indirect pattern. Direct patterning or maskless patterning, where there is a no mask and you can directly pattern different geometries. So there is a direct patterning techniques. Again, I believe that I may not have taken this thing in the part of this course. But if you are interested, there is a separate topic on understanding lithography, types of lithography, how each lithography works, what is direct printing versus projection printing versus proximity printing, and then there are physics related to the optics and how the beam will travel through the mask. What are the equations related to that? This all things are a separate topic. If you are interested, send me an email. I'll reply back to you. Okay, let me take another question, if that is okay, from the file, right? And then I'll again get back to Kaushik's question. So I think Tarannum, I have just explained a bit of lithography, but you can also send me an email. Okay. Also, I request all of you to ask me questions only related to the coursework. This live session is to clear your doubts. If it is outside the syllabus, uh, it will be it will not be a justice to students who are asking questions related to syllabus one, and I cannot keep on answering questions which are outside syllabus, because the forum is meant to only discuss the questions related to syllabus. So if you have anything which is out of your research interest, or you are stuck, or your curiosity but is not falling within the syllabus, I would request you to either ask me through an email, or you ask this question in a forum. If in a forum it is not, the TA are not able to answer your question, send me an email. I will answer a question for sure, even it is not related to your syllabus. Okay, but this live session, please make sure that you ask questions within that frame, syllabus frame. Okay, and you can also ask me some questions which are related to your exams, related to this particular course. Wherever I can, I will answer. So for example, whether this question paper will be like MCQ type. So one of the student has asked, when can we expect the hall ticket? I have no idea. To your question. Second is the exam objective type MCQ? Yes, the exam objective is on MCQ, objective type MCQ, multiple choice questions. Pattern of the exam, what is pattern of the exam? It's MCQ. So yes, that is the answer. Let me take another question from Kaushik, and the question is, can you explain the process of finding the electrical properties using MEMS and how identify the cancerous cells? Uh, yes. So see, there are multiple ways. One is, uh, one is that you can design an interdigitated electrodes, right, and load cells on interdigitated electrodes. What will happen when you design an interdigitated electrodes and load cells onto the interdigitated electrodes? You apply, you measure impedance. You will see that the cells, you cannot directly load cells, right? Cells should be in some media. So the media and cells would act as a capacitance. And because of interdigital electrodes, there will be double layer capacitance. So this double layer capacitance resistance will contribute to overall impedance Z. And when there is a normal cells versus there are cancerous cells, you will see that there would be change in impedance. Again, depending on how sensitive your sensor is. Next, if I load a drug onto a cancer cells which are loaded onto a interdigital electrodes, the cells would lyse. Lysing is dying. It dies. It ruptures. When cell ruptures, the chemical which is inside the cells would also come out. When that happens, the conductivity would increase. If the conductivity increases, impedance would decrease. So that's how the electrical measurement is done. Let me take another question. Again, it is from Kaushik. Difference between in vitro, not in vitro, it's not in vitro, it's in vitro. Then it is vitro, vitro, in vivo, ex vivo. Examples with explanation needed. Okay. Uh, okay. So let us say that uh, I have a tube which is called catheter, right? And I want to measure whether my trachea is inflamed or not, uh, whether my trachea is inflamed, right? Trachea is windpipe. So I will make a catheter that you can place inside my throat here, inside through mouth to the trachea. That is in vivo. It is inside in vivo analysis, right? Now suppose I take a tissue from my oral cavity, and I take it and I test the tissue using one of the sensors. It's ex vivo study because tissue is taken out. But if I take cells and make spheroids out of it, like grow the cells in the laboratory, make spheroids out of it, or if you have seen, they started 3D printing of organs, right? That is in vitro, because you are creating those things inside the lab and studying it. So microfluidic platform for growing cells, you are growing cells within the laboratory environment in vitro. All right. So in vivo within the body, ex vivo outside the body using the tissue, or any other sample body fluid, testing it, and in vitro is in the laboratory. That is just a very simple explanation of three terms, Kaushik. I'm sorry, uh, Tarannum, but there is a question in assignment related to this. Let me see what question you asked. See, Tarannum, there will be question related to this kind of things even in the in your exams, because you are as a student supposed to learn something which is not even taught in the class, but is related to the topic. That means if I teach you lithography, you should learn what are the other lithography techniques available with you. That's why it was a question asked in the assignment. So I expect that you as a student, not just you, all of you as a student also learn which is outside what I teach you. If I teach you a contact based lithography, you should be curious, go back and see how the maskless lithography will work, how the proximity printing will work, how the projection will work. So even it is not covered within the class, you can always look into this kind of lithography by yourself. But if still you are not able to find the topics, or you are confused, then I'll teach you again. Very difficult for me to draw on this particular platform that I am using right now, which for live session. So I cannot teach you right over here. But what I can do is I can send you the materials for the same. If you ask me or send me an email, I'll definitely reply back to you, Tarannum. Okay. I'll take another questions if that is okay. I have not talked about leaders, right? So I don't know. I'm not supposed to answer. So I'm not answering that question. Ankush, in case of direct modulated biosensor, how the biomolecules are go inside the cavity practically? Direct modulated biosensor. What does you mean by Ankush? Direct modulated biosensor? Because what I have taught is that you take the cells, all right, and you have a sensor. Let's say there's an interdigital electrodes, which is grown, which is there inside the well, right? How you can grow well is by using soft lithography or by using PDMS. So when you have a well made up of PDMS and you have interdigital electrodes below the well, you can load the cells inside the well, and the cells would be contained. If you don't have well, it will just come out, right? So you have to have a well to hold these cells, and then you can understand the impedance. But if this is what I can tell you right now, I don't know if that is what you asked, or you can ask me in detail. I will be taking questions related to sensors and actuators class. Okay. Uh, Sir, is it possible to provide a correct version of COMSOL software? No. Uh, I don't work on that kind of mechanism, and I would suggest you also not to work on that kind of correct versions, right? It is not too costly. If you ask for a student version, if your college asks for a student version, it is really affordable. So I would request you to, if you are interested, in fact, a group of you are interested to understand the simulation of these devices, it is better to ask your college or management to request for a license version, for a student license version, okay, which is easy to get. And if you want, I can get you the details of the console team who can help you out. But I would not suggest you to use correct version. Next question is Ranish. Ranish, the how is it the IDE pattern which we need over the substrate design over the mask? Will we get already pattern mask? Yes, no, no, no. You cannot get a pattern mask you have to also design a mask. And that design of the mask, I told you, right, there is a bright field mask, dark field mask, and this mask is made up of either Fe2O3 or it's a chrome mask. So to design a chrome mask, there is a mask writing facility. Once you have this mask, then if you take a, let's say, oxidized silicon substrate with chrome gold, and you perform lithography, that means you deposit. First you take silicon wafer, then you thermally grown oxide, then you deposit chrome gold or just a metal that you want to use as an interdigitated electrodes. On this metal you spin coat your photoresist, and then you soft bake and 90-degree 1 minute hot plate. Then you take this mask, load the mask. We have taught contact based lithography, so the mask will be in contact with the substrate. Then you expose the substrate using UV light, and then you unload the mask, dip this wafer inside the photoresist developer. You will have the pattern which is there on the mask if I am using positive photoresist. Yeah, thanks, Kaushik. Actually, I try to teach whatever I can with best of the abilities, but there are a lot of things that may not be covered within the 30 hours class. Also, no matter how much we try as a faculty to teach you online, there is a difference between offline class and online class. If you would be here at IISc, and if I will be teaching you, showing you the things, you can go to the laboratory and utilize those equipment. You can operate those equipment, get hands-on training. That will give you a very different kind of flavor. But thank you for your comment. So, Georgie, we said, do we? Don't say sir. But anyway, do we have to perform simulations using COMSOL in the exam? Nope, not at all. Absolutely no. I don't. I see. The reason of teaching this course is not to test your or make your life difficult. At no point of time. All these courses are meant to teach you something, right? You already know a lot of things. One small thing if you add to this will increase the horizon, the way you think about the subject, the way you think about research, right? The way you think about your electronics in a different manner. Generally classical electronics, what we think is ends as a transistor. What else, right? So I just try to teach which is little bit different than what is your normal way of learning sensors and actuators. Then what, right? How many times we will understand DC motor? What is the novelty? There is a lot of novelty. If you learn the DC motor really, there's a lot of novelty in fabricating those motors, right? But the point is that sensor transistor in a different way on application makes a lot of difference. So, but I am 100% sure you not be asked to use COMSOL in your exam. I don't know about that because I have not taken that course, Georgie. Uh, so, but there is no audio piece also. The next question would be, what are the questions, which I cannot tell you. All right. Okay, guys. So I think if you don't have any other questions, yeah. What all are the functions of HEPA filter? HEPA filter is to filter out the microparticles or contaminants from the air. It is a unidirectional filter. So when air comes inside, it has to pass through HEPA filter. The filter will filter out all the micron-sized particles and let only the clean air come inside. More number of HEPA filters, larger number of airflow circulation will improve the quality of the clean room. That's the role. Shall I send you an email requesting for some context from? Yes, absolutely. Please do. Please do. I will send you reply most probably by tomorrow. All right, Thomas. Explain the positive pressure and negative pressure. It's very simple, right? Why you need me to explain positive pressure and negative pressure? I am not going to explain this. Find it out by yourself, Kaushik. If you are taking a positive photoresist, negative photoresist, I can understand because you have never, most of you have never used that term, right? But positive pressure, negative pressure is very simple. I do it by yourself. Consider that your homework. Not going to answer. Simple questions, too simple. Not going to answer. Okay, let me take one more, one or two more questions. Okay, Kaushik, I am sure you will be able to find out the answer. Try it by yourself. Arun. Next question is from Arun. Uh, so the question is, I couldn't get what is a micro heater and its application. Okay. All right. So just for all of you, when you talk about a micro heater, the heater which is micron in dimensions, right? Now, literally, it doesn't mean that it is a micron in dimensions, but the heater components, the pattern that you use within a heater are of few microns. For example, if you draw a coil, right, and each the width of the coil is, let's say, 100 microns, and the spacing is 100 micron, that is a micro heater. It is nothing but the resistor. Resistor, generally, what is the formula? Very simple, right? R equals to Ohm's law always. No, R equals to rho L by A, right? Rho is resistivity, L is length, A is area. If I increase the length, means if I make a coil, I am increasing the length. If I reduce the area, increase the length, reduce the area, then my resistance would increase, right? If I just take a wire, single wire, and apply a voltage, right, it will have, what will happen? It is like a short circuit, right? Because it's a conducting wire. But if I make a coil out of it, becomes a resistance. So now if I apply voltage, because of the flow of current through this coil, it becomes a Joule's heating, I square R heating, and that's why it starts heating. So a resistor which is in form of coil, which will heat up when we apply a power, is called a micro heater. As simple as that. That is the first answer to your question. And second is that you say that what is application? Applications are enormous. Just example would be a gas sensor. Now, some of the questions that few of you asked is semiconducting oxides, right? And if I use semiconducting oxides, then I have to heat those oxides at a higher temperature. To heat those oxides at higher temperature, what will I do? I will use a micro heater. So there is a micro heater, or you have a silicon substrate, oxide silicon substrate. You have a micro heater, you have an insulator on which you have interdigitated electrodes, on which you have your gas sensing layer, right? Now, if I want to use this sensor at 400 degrees centigrade, I can heat my micro heater, which is integrated to this sensor. That's the role of micro heater. That is your answer to the question. Yeah, so the question by Abhay is that if I use positive photoresist pattern onto a metal which is coated on electrode, or which is coated on the substrate, and if I have the lithography done, and if I dip the wafer inside the metal etch, and why photoresist, the metal below the photoresist also not etched? What he's asking is, if let's say you have a oxidized silicon substrate, and let's assume that this is a photoresist, right? I'm not this is very bad example, but it's okay. So this is a photoresist. What he's saying that if I dip this wafer, and this is a metal, if I dip in a metal etchant, then this material gets etched. Why the material below this photoresist is not getting etched? Because chemical can go inside also, isn't it? Question is excellent. That's why a recipe and the process flow is very important. One is a process flow, how you will fabricate. Second is recipe, for how much time you will dip. After certain time only starts etching below the photoresist. So if you over etch it, you will see that there is a extra etching. If you under etch it, not get etched. Then optimized etching is important. That is the answer to your question. Next is, what is the by Alisha Das, and the question is, what is the importance of graphene is in VOC sensing, and the best fabrication technique available. Best fabrication technique is of course a microfabrication technique, a MEMS based technique. People have used recently started using graphene, but importance of graphene is one of the sensing material. That is the importance of graphene. We can use different sensing material other than graphene as well, right? So that is the answer to your question, Alisha. And I believe that we don't have any other question. Also, we are very close to our ending of our live session. So if you guys don't have any questions, I really thank all of you to for attending this particular live session, and I hope that I have answered some of the questions that you have asked. Some of the question which was outside syllabus, I am forced not to answer those questions. But at the same time, if it is related to your curiosity, and if you're not able to find the answers, please send me an email. Like Tarannum also asked one of the question. If you are stuck and you're not able to find answer for the lithography question that was asked under the assignment, If you are still not able to answer, I cannot help you to solve the assignment, unfortunately, but I can help you to find out the materials that are related to that particular question. Okay, so feel free to send me an email. Also, I'll request that the NPTEL forum is meant for the same thing. If you are stuck, ask questions. If you don't get the answer, then send me an email, and I will definitely answer your questions. All right. Same thing goes for RF MEMS also, right? Outside this one, just please send me an email. Okay, guys. So have a nice day. Have a nice time. Your exams will be somewhere coming soon. I hope you enjoy this class. And then I'll catch you sometime. If you're in Bangalore, to come in a group, right? And if you want to attend or see the labs, feel free to send me an email. And if the situation is correct and if the institute allows, I'll be very happy to show you my labs as well. All right. Take care. I'll end stream now, and all the best for your exams.